First, we need to explain method area. What is method area? You can see here, method area is the part of JVM memory that store class label information. It is shared among all threads and holds data required to describe class and interfaces. You just imagine, method area means it's a JVM memory in class level information. You just see, I am going to explain one example here. This is the class, okay? In this class, we have also present this method, right? Some variables we have, some interface also have. Those things are in this method area, right? What method are storing? Class related information, class name, super class name, package name, and access modifier. This is the actual work of method area. And methods, the bytecode, all method defined in the class. Variables, static variables, class level variables shared across all objects. This also stored in method area. Interfaces, information about implemented interfaces, runtime constant pool, a for class runtime storage area containing constant like string, numeric, literals, and reference used by the class. Okay, again I need to explain. Okay, what is class loader method area? Okay, method area is the place that class label it stores class label information, right? Class label information means it is shared among all the threads and holds data required to describe class and interfaces. Okay, class label information. What is the class label information? Class name, super class name, package name. What is the package name? You can see here package name I am already given here, this class name and this package name. Okay, then method name. If I store this int a is equal to 10, this is also a variable name, all the things. This is the work of method area to store that class label information, right? Method, the bytecode of all methods defined in the class. Then variables, static variables, interfaces, runtime constant pools also storing. This is the actual work of method area, store the class label information. Okay, heap area. We need now we'll go to discuss about heap area. In class loader, we have also heap area. You can see here, this is the method area. Once method area completed, then heap area. What happening in this heap area, we need to explain right now. Heap area is the part of JVM memory that store all objects created runtime using new. Okay, what is the heap area work? In the class, we are writing that object, okay, with new keyword. That new keyword are representing for object. What is the heap area work? Heap area is the part of JVM memory. Heap is the one type of memory in JVM that will be stores all the object it's storing at the runtime. Okay, why it's important? If heap area is there means why it's important? All runtime objects live here, okay, including arrays and class instances, garbage collection occur in the heap, automatically freeing memory from objects that are no longer referenced. Okay, you can see here one example. String YouTube channel name is equal to new string backend Guruji. Okay, this is the backend Guruji. This backend Guruji will store in heap, and this reference YouTube channel, okay, it will store in where? Stack, right? You just imagine JVM is on heap area means there will be one memory allocated under JVM, right? This JVM memory, okay. Example I am giving, there will be in one city having warehouse, okay, where all items is there. That item also as object stored. Objects are created, kept until they are no longer needed, at which point garbage collections clears out unused items. I am giving another example. You just remember it. One company also there, okay. These companies also having some product, 20 products having. Within 20 products, there will be 10 product expiry will be completed. Then what they will do? They will be remove that items, right? Similarly, garbage collectors will do the work. Then we'll go to explain Java stack. You can see here after heap area, then Java stack, right? What it is does? What is the work of Java stack? Java stack stores information about method execution and for each thread. Okay, we have thread also. Okay, that thread execution information who will store? Java stack, right? It keep track method calls, local variables, and their order, which method will be executed. What is the work of Java stack? Java stack stores the information method execution for each thread, and it will track local variables, method calls, and order which method will be executed, right? Structure. Each thread has its own Java stack, so stack are not shared between threads. Whenever a method is called, track frame is created and pushed onto the stack. When the method finishes execution, its stack frame is removed. Its stack frame stores local variable, method parameter, and local variable declare inside the method. Operand stack, return address. Operand stack, what operand stack it's doing? Used to perform immediate calculation during method execution. return address stores the address to return after the method execution complete. We need to explain again what Java Stack do. Java Stack store information about method execution. Then for each thread, it keeps track of method calls, where local variables, and order of method execution. Structure: each thread has own its Java Stack, so stack are not shared within threads. So whenever method is called, stack frame is created and pushed into one stack. When method finishes the execution, a stack frame is removed. Each stack frame stores local variables, it store operand stack, return address. We need to give one example. You can see this is the method, add method, and having a and b sum. When add method is called, stack frame is created containing a, b, sum, operand stack data, and return address. Now we'll go to explain PC register, program counter register. What is the work of program counter register? You can see here already we discussed method area, heap area, Java Stack. Then we'll go to explain PC register. Right? PC register keep tracks of the address next byte code instruction to be executed the current thread. What is the work PC register? PC register track the address, means reference of the next byte code. What will be next byte code will come, their address will be PC register track, right? Instruction to be executed current thread. Those lines of instruction that will be executed by the current thread. Why it's needed? The JVM executes byte code instruction by instruction. The PC register ensures that after executing one instruction, the JVM knows which instruction to be executed next. What is the PC register ensure? PC register ensure that after executing one instruction, the JVM knows which instruction to be executing next. Per thread, we need to go through. Each thread has its own PC register. Okay, so multiple threads can execute independently without interfering with each other. Means every thread having PC register, so multiple threads can execute independently. Okay, they are not interfering to each other. Special cases we need to see in PC register. If a thread executing native method written in language C or C++, the PC register value will be undefined, right? Example I am going to explain. Int a is equal to 10, int b is equal to 20, int c is equal to a plus b, right? Here PC register update after each line. 10 update, b 20 update, int c a plus b update. Next instruction to be executed. Then we go to explain about native stack. What is native stack, right? Native method stack, what it does? The native method stack stores information related to the execution of native methods, which are methods written non-Java languages such as C, C++. It's already the things in C or C++, right? Why it's execute? Some Java methods rely on native code, interact with operating system or hardware, low-level system resource. So for that reason only, native methods stack is required. To manage these calls efficiently, the JVM maintains separate stack that will be the native method execution. Per thread. Each thread has its own native stack similar to the Java stack. Public native void read file. You can see here this read file is executed its execution details and store the native method stack instead of Java stack because of this native keyword. Okay. Execution engine. We'll go to that picture diagram. This is the execution engine and interpret and JIT. It does execution engine. The execution engine responsible executing Java bytecode and producing final result. Right? How it works? Interpreter read bytecode instruction by instruction and execute it. Provide quick startup but slower execution and repeatedly used code. JIT. What is the JIT? JIT identify frequently executed bytecode and compiles into native machine code. Improves performance, avoiding repeated interpretation. This JIT making faster of execution. Okay. Then we'll go to execution engine completed. Then native interface. Okay. Native interface JNI. JNI Java native interface allows Java code to call and interact with native libraries written in language C or C++. Right? Why it's needed? Use case. Somewhere operations require direct access to operating system level or hardware level features that are not fully available in pure Java. So JNI is required. JNI acts as a bridge between Java programs and native code to enable these low-level operations. How it works? Java declares native method using native keyword. The actual implementation of these methods to provide native languages C++. Here one public native void open file. Open file is control transfer from Java native to code to JNI, Java native interface.